As a keystone species, bees are probably one of the most important species in the animal kingdom, so much so that without them, entire ecosystems would collapse. To us, they may just look like fuzzy little friends, but have you ever wondered how they see you and the world around us? Bees' vision is very important to them as it's how they navigate the world around them, as well as how they determine what the best flowers are. To understand how bees perceive us, we must first understand how we see the world around us, and to do so we must take a look at the electromagnetic spectrum. So what is the electromagnetic spectrum? Well, it's the complete range of all types of radiation that has electrical and magnetic fields. This ranges from gamma rays all the way to radio waves, but we're mainly going to be focusing on visible light. Visible light is a section of the electromagnetic spectrum that the human eye can view. The human eye can detect wavelengths between 380 and 700 nanometers. Bees' vision, however, is slightly shifted and shorter, as they have the ability to see in ultraviolet whilst not being able to see red. But why do they need to see in ultraviolet? Well, by shining a UV torch at this flower, we should be able to find out. As you can see, the tiny particles such as pollen glow under UV, making it easier for the bees to see. Each types of flower look different to each other, making them more or less appealing to bees. As we can see, this one is much less vibrant as compared to the other flower. This means that bees may favour it less. It is also important to know that it's not just the ability to see in different wavelengths of light that makes bees' vision different to ours. The other major difference is their eyes. Bees in fact have 5 eyes in total. They have their 2 main compound eyes, as well as 3 smaller simple eyes, which are usually located on top of their head. Compound eyes are made up of thousands of tiny little hexagons. Each of these are called ommatidiums, and honeybees have around 5,500 of these in each eye. Different insects have different numbers of ommatidiums. The more there are, the higher resolution of image they'll be able to see. Predatory insects such as dragonflies can have up to 25,000 in each eye. Each ommatidium works much like one of our eyes do. They share many similar properties, such as having a lens that lets in light, as well as some form of photoreceptor, in our case a retina. As well as having lenses, compound eyes also have crystalline cones to help focus light. These 2 elements work together to help form a dioptric apparatus. This is then refracted down into the receptor region. While bees may not have retinas, they have something similar called a rabidum. This works in a similar way, as in it processes the light and turns it into an image. You can think of each ommatidium as being lots of tiny little eyes. Each one records a small part of an image, which can then be put together like a jigsaw puzzle. Us humans have a field of view of around 180 degrees. Bees, however, have a field of view of around 300 degrees. This is not just to help them detect predators, it is also to help them navigate. You see, with a field of view so wide, it means they have a constant view of the sky. But why is that important to them? Well, bees also have the ability to see polarized light. Polarized light is where light rays from the sun reflect off molecules in the atmosphere at 90 degrees. This aligns the waves of light, causing them to oscillate along the same plane. To the bees, it will look like a band of polarized light 90 degrees from the sun. This band of light helps navigate to and from the hive. It acts as a natural compass, helping them know which direction is which. This polarized light can also be detected with their simple eyes. But what other purposes do their simple eyes serve? Also known as ocelli, which derives from the Latin word ocellus, meaning a little eye, these simple eyes can't detect images as such and are more of light sensors. These light sensors help the bees to orientate themselves towards the sun. Some bee species are crepuscular, meaning they are active from dawn till dusk. These species have adapted by having enlarged ocelli. This helps them to navigate in lower light environments. So now you know how bees see you and the world around you. Maybe now you'll see bees a little differently.